I've decided to skip question number 2. I'm actually fine with you skipping that question in your packet. It actually is pretty difficult there. But let's take a look at question 3, and then I'll do part of question 4 for you as well. I'll let you carry on. In question 3, okay, we're given a class. It has a total of 30 students, but we're given the ratio of boys to girls is 2 to 3, okay? We know the total is equal to 30, but right now the total that we have, when we add up the values together of the ratio, I have 2 and 3, that adds up to 5, right? So this is not representative. There are definitely more than 2 boys in the class, right? So it's not showing us that we have 2 boys and 3 girls in the entire class, but we're showing kind of the most simplified version of that comparison from boys to girls. So if I wanted to figure out actually how many boys and how many girls were in the class, I could figure out what I would times 5 by to get to my actual total of students, right? Because we know the actual total is 30. So if I'm comparing 5 to 30 and I want to change 5 into 30, I could think of what I need to multiply 5 by to get 30. Can you think of that number? And the answer is 6. Oops, okay, 6. So remember, we keep it consistent throughout the entire ratio. I times everything by 6. So my new value of boys, or the actual value of boys in the class, is referred by 2 times 6, which is 12. And then the value of girls in the class is 3 times 6, which is 18. Okay, so that's how much we originally start with. We had 12 boys and 18 girls. The second bit of the question says, if 6 girls, no boys, join the class, what is the new ratio of boys to girls? So look at all these girls we have. So many girls. Always better to have more girls than boys, right? Okay, so bring down my ratio. It says we joined 6 girls. So I'm going to add on 6 girls to that bit of the ratio. So I had 18 originally, and then 6 girls come in. So now we have 24. And then we keep the same number of boys, right? We don't need to change anything here going from here to here because no boys came in. We added on 6 to the number of girls, but the number of boys stayed the same. So this is my new ratio. However, I always want you to simplify. Okay. Is there any number that goes into both 12 and 24? I hope that you are thinking of the number 12. So if I divide both of these values by 12, I would come up with 12 divided 12 is 1, and 24 divided 12 is 2. Okay, so that is your simplified ratio, which will be your answer. Okay, excellent work. Okay, lastly, let's get to question 4 down below. I'll probably just do question A, and I'll try to let you figure out the rest of them on your own, okay? These are a little bit tricky, so try your best. If you do have questions, you can just email me, and I can make some more videos if you need. But try to get through them on your own. Use MathsWatch to help you out. Let's see, we have Sue, Ted, and Ben all have their birthday on the 1st of January. In 2010, Sue, Ted, and Ben all have their ages in the ratio 2 to 3 to 4. Okay, so question A, it says we have Ted's age. Okay, so I have Sue, Ted, and Ben in that order. Their ratio is 2 to 3 to 4, but we're given Ted's real age in 2010, okay? Remember, we always keep consistent the values that we multiply from one to the other in our ratio. So I started off with the ratio of 3 for Ted, but then I know his actual age is 15. So what do I times by to get from my ratio to the actual age? 3 times what is 15? The answer there is 5, which means I'll times every value in my ratio by 5. So to find Sue's age, 2 times 5 would be 10. To find Ben's age, 4 times 5 is 20. So we know Sue is 10 years old, and Ben is 20 years old, so that's Ben. Okay, so we now have their ages. All right, remember in ratios, you need to keep everything consistent. So once you find one pair, you can find the value that connects them together by multiplication, and then use that value throughout the entire question or the entire ratio to make sure that it stays consistent. Okay, remember, everybody is multiplied by the same amount. So don't decide to randomly multiply one of them by a different number. Okay, keep up the good work. Some of these questions can be really difficult. We're at the end of the ratio lesson, so they're trying to challenge you a bit here. Next week we will be working on BIDMAS, so I hope that you're excited for that. I think that's a fun lesson, and I look forward to going through BIDMAS with you, okay? Have a nice weekend. Remember to submit all of your work by today if you can, and I will speak to you later.